This video will help you solve Lab 8. In Lab 8, you are asked to implement 4 sorting techniques: the bubble sort, the insertion sort, selection sort, and the last one is the cocktail shaker sort. The pseudocodes have been given in the lab handout, so you can use the pseudocodes to convert them into working codes or working C codes. And we have already looked at the pseudocodes for bubble sort and insertion sort. We have converted the pseudocodes into equivalent C programs. There are several tasks here. So the first thing is declare an array and fill an array with 10,000 random elements between minus 50,000 and 50,000. So to do this, use the random number generator program that you have written in the last class or in the last lab assignment. Next, let's call this array as list1. Now the next step is create list2, list3, and list4, which are essentially identical copies of list1. So list3 is list1, list2 is list1, list4 is list1. You have to use a loop, and for every list, let's say list of 2 of I equals list1 of I. So we have 4 identical copies: list1, list2, list3, and list4. Okay. Now we are doing this operation because we want to perform the sorting techniques, or we want to compare the sorting techniques by sorting the same set of elements, right? Now what I'm going to do is I'm going to implement bubble sort on list 1, insertion sort on list 2, selection sort on list 3, and cocktail shaker sort on list 4. And I want to find out which sorting technique takes the least amount of time to sort the elements. So find which technique is the fastest, right? So this is how your overall program will look like. So you have your main, okay? Declare the initial array and initialize it with random numbers between 10,000 random numbers between minus 50,000 and 50,000. So using the random number generator program, okay? Make copies. So create list 2, list 3, and list 4. Okay. Now, if you want to find out how much time each sorting technique is going to take, we are not going to use a manual stopwatch. Okay. Like, we are not going to use your phone to see when it is starting and when it is ending. I mean, it's not even possible to do that. So what we are going to do is we are going to use some start timer. You can browse that in time.h header file. It's given in the handout. You might want to research a little bit on that. So before you implement a sorting technique, start the timer, implement bubble sort. Once it is done, you can say stop timer. Now the time required to perform bubble sort can be given by the stop time minus the start time. Again, how to do that, you have to research a little bit. Next, start the timer again. Implement some other sort, let's say insertion sort. Once insertion sort is done, stop the timer. The time taken to perform insertion sort can be found out by the stop time minus the start time. Do the same thing for the remaining two sorting techniques as well. And at the end, you can display the time required to implement each technique. So your console output can be something like bubble sort took XYZ seconds, insertion sort took ABC seconds, selection sort took PQR seconds, and cocktail shaker sort took JKL seconds. Now, and then you can see which technique is the fastest. So using this information, try to solve lab 8.